All right, welcome back to statistics. We're going to be talking about the binomial distribution today, right? We're going to be using the calculator to kind of help us do some calculations, and we should be able to get through the rest of this here. Okay, you go ahead and share the screen so we can do some work. All right, so here, this is take two, by the way. So this is your flight has been delayed at Denver International Airport. 86% of recent flights have arrived on time. Sample of 12 flights is studied. Round the probabilities to 4 decimal places. Okay, thank you. All right. So what we're going to do, okay, is we're going to check to see, even though I know I'm in the binomial distribution chapter, we're going to go ahead and check it to make sure anyway. Okay. Do we have two outcomes? Well, they seem to care whether or not, right? It's either on time or not. Okay, so we have our two outcomes. Our probability of success, P, is going to be 0.086 every time because we're just going to look at this global number. We have a set number of trials, and n is equal to 12. We're going to assume that they're randomly selected so that they're independent. Okay, so that probably means that we pick them up on different days. We cast a die to see whether or not what day it was going to happen, and that's how we did this. Okay, so you're not going to get like one day of bad weather and like every flight's going to be delayed. Then that's not independent. Nor are we going to pick the one day where it's like, wow, it's a sunny day and it's real easy to get in. Maybe it's a later day, so there's fewer flights. So they're all on time. We're not going to do that either. We're going to randomly pick them. Okay, so we're just going to make the assumption that that this happened. All right. So what are we doing here? We're going to say find the probability that all 12 flights were on time. So what's the probability that R is equal to 12? All right. So binomial. So we're going to say, well, this is NCR, right? This is P to the R times 1 minus P to the N minus R. Don't memorize this formula. You're going to be using the calculator in just a moment. I'll teach you to do it that way. Okay, if you guys really want this formula, I'll put it on page 5 for your quiz. But I would really prefer that you learn how to use it with the calculator and not go through and try to memorize formulas like this. All right. So for R equals 12, right, we're going to say, well, how many flights total? We have 12 flights. We're going to say 12, choose 12. Okay. P, that was going to be 0.86 raised to the, how many successes did we want? We want all 12. Okay. If something costs 86 cents and you put down $1 on the table, how much change are you supposed to expect? Right? That's going to be 0.14. Okay, so 1 minus P, that is 0.14. Okay, we started with 12 trials. We used up 12 tries. How many are left? 0. Okay, so we're just going to do this in turn. Okay, so our calculator, we're going to say, what is 12 math, B, NCR 12? Okay, it's going to be 1. And here's why. Let's say, look, I've got a dozen pieces of candy. You have to take them all. You have one choice. Like, okay, thanks. Take them all. I don't care what you do with them after that, but you got to take them all. 1. Anything, well, any non-zero number raised to the 0 is going to be 1. Okay, so this is 1. All right. And then we're going to have 0.86 raised to the 12th power. Okay, let's type that in. So we're going to have 0.86 caret 12th power. Okay, so we end up with 0.16367. Since they wanted 4 decimal places, and that's a 7, this is going to go 0.1637. 1. These are all times each other. Okay, so 1 times 0.1637 times 1. We get 0.1637. 1637. All right, that's what we're going to type in. Oh, look at that. It's already done. All right. Problem number 2. Oops, back here, you. Okay, problem number 2. We want the probability of exactly 10 of those flights. Okay, what's the probability that 10 of those flights is on time? So the next section, PR is equal to 10. All right. So same formula up here, right? We have NCR P to the R 1 minus P to the N minus R. Okay. So N is going to be 12. We're choosing 10 of them. Okay. P is going to be 0.86. How many successes do we want this time? We want 10. Okay. 0.14 for the same reason it was here, right? 1 minus 0.86 is 0.14. And we have 12 attempts. We want 10 to be successes. How many do we have left? We have 2 left. So what we're going to do is we're going to say, okay, well, this is going to be a little bit more involved. So this is 12 math over to PRP down to NCR to 10. 66. I'm going to say 0.86 raised to the 10th power. Right, and this was 0.22. What do we have here? 2213 times, and we're going to have 0.14. 14 squared. Oops, not that. Squared equals, and that was 0.0196. We're just going to times these all together again. Okay, so we have 66 times 0.2213 times 0.0196, and lo and behold, we have there's our answer here, 0.28627. 28627. We went around to 4 decimal places, so our answer is actually going to be 0.2863. All right, and there we have it. Now, again, I've already typed that in. All right, 0.2863. So now we're going to learn how to use the calculator. Okay. So what we're going to be doing with the calculator is we're going to hit the second function, distr, okay? And it's going to bring up a whole bunch of options. We're going to scroll down using the arrow keys down to where it says binomial, okay? Binomial PDF and CDF. Which one do you use? Well, binomial PDF. PDF stands for a probability density function. Okay, a binomial CDF. This is a cumulative density function. Right? The PDF is for a particular value. The CDF is for a collection of values. Okay, so this is for a particular value, kind of like what we have in part A and part B here. They want for 12, that's a particular value, and they want for 10, that's a particular value. Okay, the next one, we're going to get a collection of values, and that goes from 0 up to the number they specified. 0 up to R, up to and including. All right. So for a PDF, that's the particular value. What we're going to do is we're going to type in binomial PDF. Okay, if you're using 83, calc 83, you kind of have to memorize like what order this goes in. If you have an 84, it will prompt you. It'll give you like, what do you want N to be? And then what do you want P to be? This is your probability of success. And then what do you want your X or your R to be? Okay, they're going to use X. All right, and you're just going to type those in. So binomial PDF. Okay, we're going to say, well, we have 12 airplanes, 12 flights. We have a probability of 86% that they're going to be on time. And we are interested in all of them being on time. Okay, so my particular value here is 12. So we'll just write that down. Binomial PDF of 12.86, 12, all of them. All right. What do we end up with? We end up with 0.16367. 6367. Look what we had up here. Okay. This was 0.16367. So it's going to be the same thing. We're going to round it to 4 decimal places. Okay, so that's going to change. So it's going to be 0.1637. Okay, so that agrees in both cases. Okay, that's what we do. This was part A. For part B, we're going to be doing this a lot, by the way. Binomial PDF. Right, this is part B. So we still have a collection of 12 things. We want probability of success 0.86. And then how many did we want for successes? In this case, the particular value is 10. Okay, and we're just going to recalculate that. So that's going to be the second function, distribution. Scroll down to where it says PDF, binomial PDF. That would be this guy right here. All right, we're going to say 12. What's my probability of success? 0.86. And then we wanted 10 online flights here. Okay, what's the probability of 10 of them? And we end up with 0.28627. 28627, which is going to round up, right? So we have 0.2863. And we could check up what's happened. When we did it by hand, we could check, hey, we got exactly the same number here. Okay, and that's what's supposed to happen. All right. Now, we do our next problem. Okay, they want 10 or more flights were on time. Okay, so we have a collection. We have, okay, if we have to do this by hand, okay, what we're going to have is we want the probability that R is equal to 10 plus the probability that R is equal to 11 plus the probability that R is equal to 12. 10 or more flights being on time. So all of these. So we'd have to calculate each one of these and then add them up. This one's not so bad. They already made us calculate this one. They already made us calculate this one. Calculating one more and then adding, not that big of a deal. Okay, but they're going to be less nice about it. Okay, so we want the probability of 10 or more. So what we're going to do, the cumulative function would go from 0 up to a certain number. 10 has to be in this collection. Okay, so we're going to break our distribution into 2 pieces. We're going to say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the cumulative function will tell us what all the sum of all of this stuff is. Okay, we'll just call it X. What's left? Well, what's left is the 10, 11, 12. And I don't know what this is going to be yet. This is going to be our answer, but this is what we're interested in, right? 10, 11, and 12. What do X and Y have to add up to? They have to add up to 1. So Y is going to equal 1 minus this stuff. Okay? So since this is what the cumulative distribution is going to tell us, we're going to type in the CDF part, right? This is CDF up to 9, all right? And then we're going to subtract that from 1, and that's going to be our value here. Okay, so what we're going to do is we're going to do binomial CDF we have the number of trials, the probability of success, and then the number we went up to. Well, 10 or more, 10 has to be in this grouping. So we're going to only go up to 9. All right, we're going to write that down. So distribution, okay, we're going to scroll down to where it says binomial CDF. Okay, I went up because it was easier to do that. Okay, binomial CDF. Okay, and enter that in. So we're going to say this is 12. Okay, 0.86, and then what are we trying to go up to? We're trying to go up to 9. Enter. Okay, and this was 0.2303. Plus, I don't know what 10, 11, and 12 are yet, but whatever it is, these two have to equal 1. All right, so 1 minus, give me a moment. Okay, so 1 minus, okay, 1 minus 0.2303 is going to be my x. All right, so 1 minus 0.2303. You could have done this like a more clever way and have more decimal places, but since they only want 4, let's just go with 4. All right, so we end up with x is equal to 0.7697. Okay, so we're going to write down 0.7697. That's going to be the answer we're going to type in. All right. So let's see here. 0.7697. Would it be unusual for 11 or more flights to be on time? Oh boy. All right. So we could do the same thing with 11. We're going to be a little bit more clever though. 7697. Do we know the probability for 10? So this is the probability for 10, 11, and 12, isn't it? If we subtract out the 10, that should just be 11 and 12. So we know 10, right? We know 10. We wrote that down earlier. That would be up here. 10 was 2863. So we're going to subtract out 2863, and that should be 11 or 12 the flights. Okay. So here we have 7697 minus 2863. We ended up with about half, 4834. All right. Let's double check. So if we take distribution, okay, we go to the CDF. And what we're going to do is we're going to go from 1 to 10, inclusive, or 0 to 10 rather, inclusive of the 10. So we're going to go from 0, 1, 2, 3, 4, 9, and 10. What do we have left? 11 and 12. So what is this probability they're going to give us? Well, it's going to give us the binomial CDF part. So that's 12 flights. We have 0.86 as our probability of success, and we're going up to 10. All right. We ended up with 0.51658, which is really 0.516566, right? Because we round up by 1. All right, so the 11 or 12, that's going to be 1 minus whatever this number is. All right, and what are we going to end up with? We're going to say 1 minus that answer. All right, so there's multiple ways of getting this. And we end up with 0.483411, etc. So at the 4 decimal places, we're going to be here. Again, both of the ways we did it agree, so we should be okay. All right. So what is that? 4834. 34. So for something to be unusual, it's got to be less than 5%. Okay, this is less than 50%, but it's almost 50%, so that's not that unusual. So it would not be unusual, okay, because it doesn't fall under the 5% of the time. Would it be unusual for 11 or more flights to be on time? Well, this is the probability, so it's not unusual. Okay, my fingers are crossed, and okay, we're good. Okay, let's do one or two more, and then we can jump to the next ones. All right. Okay. So of all the registered automobiles in a city, 10% fail the emissions test. Okay, we have 13 cars selected. Right? Round the answers to at least 4 decimal places. Okay, we're going to do all of this with the calculator. Okay, so it's not going to be quite as long. Most of your homework should be done like in this manner, so it's not going to take you forever to do this. All right. So what we're going to do is we're going to say we have our total, excuse me, is 13. Okay, our probability of success is really not a success, right? They say 10% fail, but we're interested in the failures. So that's our probability of success, is the 10% who fail. All right. We're going to assume that, right, you can have, 2 outcomes, they pass or they fail. All right, so that's 2 outcomes. We're going to assume that we're just taking 13 cars from like random emission places on different days to see if there's, limiting any kind of error. If a emissions place, right, is next to a repair center, they don't want to, they'll fail everybody so that they get extra money or something. We're not doing any of that. Okay, so we're just randomly selecting all of these. All right, so they want to know what is the probability exactly 5 of them pass the test. Okay, so A is they want R is equal to 5. So just to set it up in words, right, we have 13 choose 5. Okay, we have 0.10 raised to the 5th power. If something nothing costs 10 cents, but if something were to cost 10 cents, what would be your change? Right, this would be 90 cents, so 0.90. We have 13 attempts. We have 5 of them used up. How many attempts do we have left? That would be 8. Okay, so we would go through and calculate that. As a matter of fact, let's go through and calculate that. So we're going to go to distributions. We want the PDF because we are interested in a particular value, specifically the 5th one. Okay, so PDF, so we're going to type in, we're going to say 13 trials. We have a success rate of 0.10, okay? And we want to know what's the probability that exactly 5 of them pass, or 5 of them fail, rather. Sometimes the English on these is the hardest part. Okay, 5 of them fail. And we got 0.0055. Okay, so 0.0055. That's our probability. Okay, so fewer than 5%. This would be unusual. So if we move the decimal place 2 places, right? It's under 5%. It's 0.5%. Okay, so we're going to say 0.0055. 0.0055. Okay. What is the probability that fewer of them pass or fail the test? Okay, so now we want fewer of them to fail. Okay, so this is fewer than 5. Okay, here's the hard part. Is 5 fewer than 5? Right? Is 5 fewer than 5? No, it is not. Okay, so what we're looking for is 0, 1, 2, 3, and 4. Okay, that's a cumulative distribution. So we're going to do binomial CDF. Okay, we want 13 possibilities. A probability of failure, well, probability of getting the answer we want, which is the failing of the test, 10%. Okay, we're going to go up to 4. Okay, that's our cumulative distribution. So we're going to say second function distribution. We're going to go to binom CDF. All right, going to be 13, comma, 0.1, comma, 4. And we have 0.99353. We're going to round to 4 decimal places, so we don't need that. So this is simply 0.9935. 0.9935. Okay, that's the probability that fewer than 5 of them fail the test. Right. More than 4. What's more than 4? Is 5 more than 4? 5. 5 is more than 4. 5, 6, 7, all the way up to 12 and 13. So this is simply the complement, right? This is simply the complement of the previous answer. So we just want 1 minus 0.9935. Okay. All right. So we're just going to say 1 minus the previous answer. Right? 0.00646, which is going to round, right? It's going to round to 65, 0.0065. Okay, again, it's less than 1%. Okay, so if we move the decimal place 2 places, right, that's 0.65%. We don't care about the percent so much, but sometimes people ask. Okay, so probably that more than 4, 0.0065. All right. Would it be unusual for fewer of them to fail the test? Probability that R is it 3 or fewer, or there's fewer than 3? Fewer than 3. What numbers are fewer than 3? 0, 1, and 2. 3 is not included in here. Okay, so we want the probability that R is less than or equal to 2. That's the cumulative distribution, right? We want 0, 1, and 2. So we're going to do binom CDF, right? We have 13 cars. We have a 0.10 chance of success, and then we're going to go up to 2. All right. So we're going to go second function, distribution, to the CDF one. Okay, we're going to say 13, comma, 0.10, comma, 2. 0.1, 0.10, it doesn't matter. Okay. Add 0.8661. Okay. So would it be unusual that fewer than 2 failed that test? No. Okay. In the previous years, previous books, okay, they would really try to mess with you on these, and I think that was wrong. You would say which probability that they passed the test, which in case you'd have to say, okay, well, pass the test is a 90% chance, so we have to change everything and change it to a 90%. So you'd really have to be careful when you're reading these things. Your book doesn't do this. I never like the fact that the books do this. These problems are hard enough without them playing little word tricks on us. So we're not going to worry about that. So it's 0.8661. Right. So is it unusual? No, it would not be unusual for fewer than 3 to fail the test, because the probability of failing the test for 3 or fewer is pretty high. Delightful. I'm going to go ahead and put an end to this now, the end of the video. There's nothing I can do about the traffic. And let you guys do that, and I'll do the next 4 of them in the next video. Okay, so take care, practice, Okay, we'll do them all with the calculator, so you'll get practice at that. Okay. All right. Very good.